Okay, well, good morning, and we'll take a look at today's content. Before I get into, I guess, lecture material, I do want to give you some kind of tips on how you should have your RStudio set up, how you should kind of interact with R in RStudio, and I think this will just kind of make your life easier and better. These are my opinions, but I do think they are they're good. So one thing is you should have a folder for this class, and within that folder you should make separate folders on your computer for each homework. So create a folder for homework 1, a folder for homework 2, a folder for homework 3, so on and so forth, and you'll put all of the related files into each homework folder. So for example, under homework 1, there's a few files that you need to download, one of them being monthnames.txt, as well as the RMD file that you will download. And when you do that, that will just kind of help keep things organized on your computer, okay? One thing about when you name your folders, I strongly recommend that you do not use spaces, okay? Get in the habit of using underscores instead of spaces as far as file names and folder names. And the reason why is that probably at some point in the future, you will use the command line, okay? Either through Git or just at just some point you'll have to use the command line. And when you're using the command line, life is just easier if there's no spaces. Because if you have a space in a folder name or a file name, you have to kind of escape out the name. You have to use kind of a backtick, et cetera, et cetera, et cetera. And so, life is just kind of a little bit easier, a little bit if you don't have any spaces in there, okay? Once you have your folder, if you open up the file from your folder, then R should automatically kind of set that folder to your working directory, but it's also a good idea to, in the menu in RStudio, under Session, you'll go to Set Working Directory to Source File Location, okay? And when you do that, that should tell R this is the location where it's going to be searching for any kind of files or objects or items there, okay? You don't want to just, when you click download, it probably just goes to your downloads folder. Don't just open up the RMD file from your downloads folder, okay? Download it, move it over into your homework folder, and then open it from your homework folder. Because if you just do it straight from your downloads, then R is going to be looking in your downloads folder there, okay? If you have your source working directory set up incorrectly, you might encounter this error message or this warning, okay? You might encounter something like this. Cannot open file monthnames.txt, no such file or directory, or error in file this, cannot open the connection. As you code, it's going to be important that you learn how to read error messages, okay? As people new to programming and new to coding, one thing that people often struggle with in the beginning is that when they encounter an error message, they just kind of throw up their hands and say, oh, I don't know what to do, all right? But a lot of times there's a lot of good information in the error message, okay? So if you read through it and you see, oh, there's no such file or directory, then you go, okay, you know what? I know this file exists, but R doesn't think it exists. So what's going on? Maybe this file is not located in the location where R is looking, all right? Cannot open the connection. Basically, it's just trying to open this file, and it can't do that. So when you encounter an error message, encounter a warning, read through it and see if you can understand what R is trying to communicate in the warnings or the error messages, rather than just kind of throwing your hands up and saying, well, I don't know what this means, okay? Red text doesn't necessarily mean it's an error, okay? It will often say error if it's an error, or it will say warning if it's a warning. And sometimes it's just a message, okay? So for example, when you do something like load up, say, the tidyverse, okay, you get messages, all right, and these aren't even errors or warnings, okay? You'll get something like conflicts or whatever, but this isn't necessarily a problem, okay? This is just kind of the computer telling you stuff. So this is something that could happen, okay? As you work, another important thing that you should do is you should periodically clear out your environment. So as you kind of work in R, you can kind of create objects and you get x is 9, and that's going to appear in the environment. You say, hey, here's this value x, and it has the value 9, and you can do like x plus 1 is 10 and something like that, and that works just fine there, okay? And then if you want to clear out the objects in your environment, you can hit the erase button, and it will clear it out, and you'll see your environment is empty, okay? So again, here we have that. Now, as you, this is also a command that you can type in to delete everything from your environment. So if you want to include this in your script, this will also delete everything out of your environment as well. A common thing that students will say, all right, and so this is going to be important. As you work on your homework, periodically knit your homework file and just see if it knits. You don't want to just kind of work through everything and save it to the end, like 10 minutes before the deadline, and then try knitting for the first time, because you'll almost certainly run into some kind of problem. So as you are working, basically every time you save your file, just try knitting it and see if it knits, okay? But a common thing that students run into is they'll say something like, my code runs in R, but when I try to knit, I keep getting errors and I can't knit the thing, okay? And it's a sad thing if that happens, but I'm not going to give you like extra time for your homework, okay? It's your responsibility to kind of make sure that your homework is knitting properly as you're working on it. So for example, you have this R Markdown file, and you might have this thing where you kind of run this thing, and it runs just fine. It says x plus 1 is 10, okay? But then if I try to knit this file, what happens? I click knit, right? And it shows up down here. It's rendering, and then I get this error message, and it says quitting, execution halted, error object X not found, okay? What's going on? It says the object is missing, right? The object X is not found. But again, it feels confusing because I can click this little code chunk and I can run it and it looks like it's running, okay? The problem is that when R knits a file, it always starts off with an empty environment, okay? So this is the start of my file. And if I clear out my environment here, and I try to knit this code, all right, so I start off with the first code chunk, that runs fine, and then I try to run this code chunk, then we encounter the error message, object X not found, okay? And we look at our code and we say, oh yeah, you know what? Nowhere in my code did I actually define what the value X is. What happened is that in my console, I wrote something like X gets the value 9 here, and so this value X exists in the object X exists in my environment, and then so when I click run my code chunk, this runs just fine, okay? But in the R Markdown file, I never created the object X, and therefore, when I try to knit the file, okay, and it starts off with an empty environment, it's not able to do it, okay? And so this can be resolved by just kind of adding the line, and I can say X gets the value 9 here, and then I can knit, and it knits just fine, okay? So this is a kind of a very common thing, is that in the console, students will either create objects or modify objects, or even in the code, you will create objects or modify objects, and then later on you'll delete that line of code, or you'll do something where that line of code doesn't exist in the R Markdown thing, and then when you try to knit it, it runs into problems. And so you can kind of resolve these things by clearing out the environment and then running each code chunk one by one and seeing if it runs. Okay, so here it runs just fine because I create the value 9 and then I add the value 1 to X. So this is kind of a common thing, and if you run into that issue, I would tell you to just kind of go through code chunk by code chunk. Another thing A lot of times when you encounter error messages, it will tell you like where the error message occurred. So here, if I get rid of that and I try to knit, it will tell me like where the error message occurred, and so that will be, it will say quitting from lines 18 to 19. This is where it encountered the message. Okay. Another kind of thing that you can do in a pinch, if you can't figure out why your thing is failing, you can start off a new R Markdown document. Okay. You try knitting this and you say, oh, okay, you know what, this works just fine. And then you will start by kind of deleting everything. Right? So you start off by kind of deleting everything, you knit it, and you say, okay, well, that rendered fine. And then you copy code chunk by code chunk from the document that's not working into the new document that is working, and you try to knit after every code chunk that you copy. And then when you encounter the problem, you know that the error exists in that last code chunk that you copied over. And that will also help you figure out what's going on. Because half the problem is like figuring out where things are going wrong. So if you're looking at the kind of the messages and you can't figure out what's going on, you can kind of copy code chunk by code chunk to figure that out. Yeah, so again, clearing the environment helps avoid this problem where it seems like the code runs in R, but it doesn't work when it's knitting, and you can do that. Another thing, I didn't put these in the notes, but this applies to anyone where they're using their computer in basically a foreign language. Okay, so if some of you might be running R and the language is not set to English, and when you try to knit, you might encounter this kind of like Unicode error message, and it'll say like latex doesn't, can't do this Unicode character or something like that. Okay. Or another common thing that happens is, let's see, sometimes, sometimes you'll copy something from the internet and you'll put it into your code. All right, so let me, so if I say like, hello, okay, and I try to copy this, let me see if this, and I put this in here, and I try to knit, I might get, okay, well, I got that message, maybe, let me see. Oh no, that works just fine. Let me see. Sometimes you copy something and you try to knit, and then it will encounter some kind of error message. No, this is okay. I'm not having any problems here. But okay, but all to say is that sometimes we have these characters. Okay, so this is different. This dash here, this is called an M dash, and it's different from just the plain old hyphen on your keyboard. It's different from something like, sometimes these characters appear here and it breaks down our ability to kind of knit the file. And this could also happen with foreign characters. And so what often happens is if you're working in R in a foreign language and you encounter error messages, oftentimes those error messages appear in that language and uses foreign characters. And that often throws problems in LaTeX when LaTeX is trying to render the document. And so my recommendation, and I recognize that this is very kind of ethnocentric, but I would recommend using R in the English language, okay? And make sure your error messages appear in the English language. And another benefit of that is that when you do encounter error messages, you can often highlight that error message, put it into Google or some search engine, and search for what does this error message mean. And generally, when you search for an error message in English, you will find many more results and many more answers to that particular error message than if you were to search for the error message in a foreign language. Okay, because then you have basically responses in from everybody who's using kind of English language. And so the default is that coding for the most part is done in English. And so I recommend changing your language settings to be English. You can search for the English error messages, and those English error messages won't be causing problems when it comes to knitting. Another thing is in your global options, set your workspace to never kind of restore your R data at startup and never save R data on exit. Okay, and the reason for that is if you have objects getting loaded when R starts up, that could change perhaps the behavior of R, and so it could basically cause a little bit of issues. So I recommend leaving these things unchecked. Okay, leave this unchecked and set this to never. And that way you'll save things, which is it forces you to save things. That's a good habit, and things don't get loaded up automatically. Okay, you can kind of toggle comments on your code. So if there's like a bunch of code that you want to comment out, you can just kind of highlight those lines of code. Command-Shift-C will put little hash marks in front of them. Command-Shift-C again will undo those hash marks. So this will kind of toggle comments for this code on and off, so you can kind of just remove a code chunk from running without actually removing those lines of code. A couple other handy keyboard shortcuts. You can create new R scripts. You can kind of run lines of code by hitting Control or Command Enter and things like that. You can also kind of clear out the console or restart your R using these keyboard shortcuts here. Okay, let me give you your first view quiz answer. Today's first view quiz answer is the letter E. E as an elephant. Okay, let's look at some basic data structures. A lot of this stuff comes from Hadley Wickham's book, Advanced R. This stuff comes from the first edition, and he released a second edition where he updated these chapters. And so that will be, this is your kind of assigned reading for today's content. I believe all of you are familiar with vectors in R. You've all taken Stats 20. And there are kind of two types of vectors that we deal with, atomic vectors and generic vectors. And the key difference between atomic vectors and generic vectors is that an atomic vector, all of the values have to be of the same data type. So we have 6 basic data types in R. 4 of them we use frequently, and the other 2 we don't use as much, but we have logical, double, integer, and character. Those we use frequently. We also have complex values for things with in the complex number plane, and raw values are kind of hexadecimal things. The ones we use frequently, logical, are basically our true, false, Boolean values. Double are values, double precision floating point is where the name double comes from. That's used for anything with a decimal point. Integers are basically whole numbers, positive and negative, the integer number line. And characters are basically used for string data. R automatically converts between doubles and integers, and these numeric types done automatically. So we often don't need to distinguish too much between doubles and integers. But doubles are used for whenever we have floating point values. And we will talk about some of the subtleties of floating point number arithmetic, because floating point numbers are very different from real numbers. So we feel like things with decimal values are like real numbers that you could represent, the square root of 2 and pi and things like that. But in floating point numbers, we actually can't represent those values exactly. We just have approximations for them. And so that creates some important distinctions. And we'll talk about that later. Okay. The default numeric type is double, the floating point number. Integers can be created by using the letter L after the number. Anytime you use the colon operator, that also creates an integer thing. So if you combine the values 1, 2, 3 with the function c, you do c 1, 2, 3. That will be type double. 1:3 will produce integer type. Is double the number 1? That's true. 1L though is an integer. So we've talked about atomic vectors. That's a one-dimensional data structure. If you have your one-dimensional data structure has values of different types, that would be a list. Okay. Two-dimensional data structures where everything's of the same data type is a matrix. And if you have different data types in your two-dimensional structure, that's a data frame. And then anything that's more than two-dimensional, we can have that, an n-dimensional thing with all of the same data type. That would be an array, okay? Or in other languages, we might call that a tensor, but basically, a 3 or 4-dimensional data structure that has all of the same data type, okay? Every kind of vector, all of these objects, we can assign attributes to them. Attributes is basically a list of just arbitrary information attached to it, okay? You can think of an attribute as kind of like, when you order something online, it gets shipped to you in a box, and inside that box there might be a piece of paper with here's information about your order, okay? That piece of paper contains information about the object, but if somebody wanted to, they could draw a little smiley face, they could draw a little additional note on that piece of paper, and that just kind of is thrown in there, and that exists as well. And similarly, attributes is kind of this list where there's important attributes like the dimension and the class attribute, those are important, but then you could also add arbitrary information there as well, to the attributes as well. Okay, the dimension attribute can turn vectors into matrices or arrays, and then the class attribute powers our object-oriented system S3, which informs our how to interact or behave around things. Okay, I have a couple questions here for a self-quiz when you study these notes on your own time later. So, for example, here's a data frame. A data frame is internally stored as a list. It's a list of multiple vectors of same length, but we have attributes in there. So I can ask, so here's the head, the first 6 rows of my data frame, and it looks like a table, okay? And I've got this column girth, column height, column volume, information about a tree, and row names 1, 2, 3, 4, 5, 6. We can ask, what are the attributes here? And the attributes is a list. It gives us the names attribute, which is the column names, girth, height, and volume. It gives us the class attribute and tells us that it's a data frame. And the row names, which is not interesting to us, but this tells us that there are 31 rows, and the names are 1, 2, 3, 4, 5, 6, etc. Now again, attributes is just an arbitrary list, and so if I wanted to, I could add an attribute. And so here I use the function attr, and I'm going to add the attribute to the object trees, and the attribute name that I'm adding is info, and I'm just putting in this little character string that says this data frame is about trees, okay? Again, it's kind of like just putting a little note on that piece of paper that gets included with your order. And so now if I ask what are the attributes, it now contains this line that says this data frame is about trees, which is not standard. This is not something we would normally do, but again, attributes are just an arbitrary list where you can kind of add arbitrary information that you want. But again, the important attributes will be things like the class, and if applicable, the dimension. So matrices, R knows that an atomic vector is a matrix by looking for the dimension attribute. So here I create an atomic vector with the integers 1 through 10. And so M is an atomic vector, values 1 through 10. And if I ask, hey, what is the class of M? It's going to say this is an integer vector. Now I could add an attribute using the ATTR function. The ATTR function, I'm going to say add the dimension attribute. The dimension attribute is going to have the value 2, 5, or 2, 5. And so that tells R this object M now has dimensions 2 by 5, 2 rows, 5 columns, and it's going to reflow these 10 values into a matrix. And the way R works with matrices is it goes down the columns. So it's going to go 1, 2 for the first column, 3, 4 in the next column, 5, 6 in the next column, and so on and so forth. This is different from, say, Python's behavior. In Python, if you take a NumPy array and then you change the dimensions, it will reflow row-wise. R will reflow column-wise. So now if we ask, what are the attributes of M? It says, hey, this is the attributes that you created. It's got a dimension attribute, 2, 5, 2 rows, 5 columns. And if I ask, what is the class of M? So again, same object, the M, we've just taken this integer vector, we've added the dimension attribute, and now the class is now a matrix, which is, I guess, a two-dimensional array. So this is kind of, classes can have multiple things. There's a hierarchy. You have arrays, and all matrices are forms of arrays. Kind of like you'll have, parallelogram. Rectangles are all classes of parallelograms, and squares are classes of rectangles or things like that, right? Or subclasses, yeah.
So when we alter the dimension attribute, does it also alter the class attribute to match, or does it only do check?
Okay. So what happens is when you ask for the class of an object, R does a few things, and it will check if there's a dimension attribute. And when it recognizes that there is a dimension attribute attached to an atomic vector, then it will say the class is matrix and array. So yes, when you alter the dimension attribute, it kind of immediately also alters the class, but it's a little bit strange. In that it's kind of like this, Schrodinger's box. Does R know that it's a class matrix until you ask it? And I'm not sure. But every time, but basically, as soon as it has the dimension attribute, every time R interacts with it, it's going to treat it like a matrix and an array, even if you didn't ask specifically, is it a matrix or array? You can get rid of the dimension attribute by assigning null. Okay, null is what we use to say something doesn't exist, and we will say, hey, get rid of the dimension, and we're going to just null out the dimension attribute. Okay, and so when you do this, the dimension attribute just gets disappeared. Okay, this nulls out the dimension attribute, and so M reverts back into an integer vector. And if I ask what's the class of M, it will say it's an integer vector now. Here is a dimension attribute where I've got 3 dimensions, 2 by 3 by 2. So here I have the integer vector 1 through 12, and I say make 2 rows, 3 columns, 2 layers. Okay, 2 rows, 3 columns, 2 layers, and that's what we have. So I get 2 rows. So R fills out down the column first. So it fills out the 2 rows, then the 3 columns, then the 2 layers. So it's going to get 1 through 6 on the first layer, and then 7 through 12 on the second layer. Of course, you can also just create an array using the array function as well. If we go back to a data frame, data frames are internally stored as lists where the vectors are equal length. And so here the attributes for the list are that we have the class of the data frame is data frame, but internally if you ask what's the type of this data frame, internally it's a list. We also have factors. Factors are used to represent categorical variables, but internally, factors are stored as integer vectors, where you have these attributes for level and class. And so here I've got this character vector called gender, and I got the characters M, F, F, X, M, and F. Okay, so that's a character vector. And I could say create a factor out of it. So I'm going to do factor on gender, and that's going to produce the gender factor, okay? And so this now has the values m, f, f, x, m, and f. They don't have quotes around it to kind of, that's how factors get printed out. And it also gets, prints out this thing that says the levels that we see in this vector are f, m, and x. And you could say, hey, what are the levels on this factor? And it says the levels that we have are f, m, and x. And what's the type of? Okay, internally it's stored as an integer. If we ask what is the class of this object will be a factor. Okay. If you say, hey, well, what are the integer values? I could say as.integer of this factor, and it says 2, 1, 1, 3, 2, 1. Okay. Basically, you look at the levels here, and anytime there's an f, that's going to be a 1. Okay. The 2's are m, and the 3 are x. So m gets coded as integer 2, f gets coded as integer 1, x gets coded as integer 3, and then when you ask R to print back the factor, basically every time it sees a 2, it's going to replace it with the m. Every time it sees a 1, it replaces with an f. The 3 gets replaced with an x. So that's going to be how factors work there. This can lead to some perhaps unexpected behaviors if you're not careful. Okay, so if you have some values and you turn them into a factor, okay, so if you have 0, 1, 10, 5, so I would say this is not something you do intentionally, but what could happen is you read in a data set, okay, and when you read in a data set, you have a column where it's mostly numbers, but perhaps you have some words in there. Okay, so you might have like dashes to indicate something is missing, or something, and you have a question mark if something is a missing value. And then so R reads that in, and it encounters these things that aren't numbers, and it says, okay, well, let's turn this into characters, or let's turn this into a factor. All right, and that could end up creating something where it looks like numbers, but it's being treated as a factor. So here I've got these numbers 0, 1, 10, and 5, and I say, hey, let's make, and then it ends up as a factor somehow. So here I have x as a factor, and it says the levels are 0, 1, 5, and 10. And then if you ask for something like, what is the mean? Well, it's going to say, I can't calculate the mean of a factor, because factors are for categorical variables. So it doesn't really make sense to calculate the mean, right? Like if you think about, what's a categorical variable? Perhaps your hair color. And you say, you got black hair, brown hair, blonde hair, red hair, I don't know, something else, okay? And if you say, hey, what's the average, or what's the mean hair color, that question doesn't quite make sense, right? Or what is the mean brand of car, okay? That's something that doesn't quite make sense. It's a categorical variable. And so similarly, R says, hey, you got these categorical values, 0, 1, 10, and 5, and you say, hey, what's the mean? And you go, and it says I can't do that. So you might say, well, hang on, R. These are numbers. Please give me the mean of these numbers. So you might say, okay, well, let's do as numeric on the factor, okay? And you say, give me mean on as numeric factor. And R says, okay, well, I turned it into numbers, and the mean is 2.5. And if you're not paying attention, you might be like, okay, 2.5, let's go on our way. But if you think about it, what is the mean of 0, 1, 10, and 5? 0 plus 1 plus 10 plus 5, that adds up to 16. I've got 4 numbers. 16 divided by 4 should be 4, and yet I'm getting 2.5. So what's going on? Well, when you do as numeric x factor, okay, remember internally it's stored as an integer. Okay, so internally 0, 1, 10, 5 is a 1, 2, 4, and 3. Okay, that's what's going on, 1, 2, 4, 3. And you say, hey, what's the mean of 1, 2, 4, 3? Yeah, that's going to be 2.5. So that's why we're getting 2.5 here. But again, unless you're paying attention, you might not notice that something is off, right? So, so if you actually wanted to get the mean of the value and have the mean before, you first have to convert the factor into characters, and you'll get 0 in quotes, 1 in quotes, 10 in quotes, 5 in quotes. Then you turn that into a number, and then you'll get 0, 1, 10, and 5 as numbers, and then you can calculate the mean there. 0, 1, 10, 5. The mean of that is 4. That's kind of a bunch of hoops to jump through, and this would have been avoided if the numbers weren't a factor in the first place. Okay, so just kind of make sure that when you import data, when you're working with data, that they are the proper numeric type. And that's going to just save a lot of headaches early on. So a lot of data science is not fun in that it's just like grunt work of cleaning up your data, making sure that numbers are numbers and not being turned into characters and things like that. So that represents kind of a large part. Now, there are things that do look like numbers, but are actually categorical variables. So for example, your area code, right? You have a phone number, you have an area code. That area code looks like a number, but it's not a numeric variable. It is a categorical variable. So if you have, say, area code, this is how you can tell if something is a numeric variable or not. You ask, does it make sense for me to compare two numbers? And does it make sense to take the average? So if somebody is age 18 and someone's age 20, you can make a comparison. You could say this 20-year-old is 2 years older than the 18-year-old. That comparison makes sense. What's the average age of these two people? 18 and 20, the average age is 19. Okay, that makes sense. Okay, area code 310, area code 562. Does it make sense to say person 2 has 252 more area code than person 1? That doesn't make sense. What's the average area code? Also doesn't quite make sense. So, things like zip code also, there isn't a numeric meaning behind it. And it doesn't make sense to say, I have more zip code than you, ha ha ha. That's not a thing there, okay? So yeah, if it's not, if it doesn't make sense to do that kind of numeric comparison, it's not going to be a numeric variable here. All right, let me give you your second view quiz answer. Second view quiz answer is the letter B. B as in bear, B. A couple other things about factors. You can't throw in values that aren't part of the levels. So if I try to assign the second value, the character string male to the second value, it's going to generate an NA because the only values that are allowed are in the levels, F, M, and X, and so it generates an NA there. R does coercion, and it does it kind of automatically. And so just kind of looking at our four basic data types, logical, which are true, false values. So the way R stores true is all caps true and all caps false. Okay, these are the, this is how true gets stored. I is an integer vector with the value 1L. D is a type double, 567. And CH is a character vector with the values A and B. In general, don't create objects in R with the name C, okay? Why? Because you have this function, C, which is very important that we use for creating vectors, okay? And so especially, do not ever create a function called C, because once you do that, then that will kind of overwrite this very important function that we need to create vectors, okay? So don't create functions named C. Okay, so when we combine atomic vectors of different types, what R will do is it will coerce everything into the least restrictive of the data types. So these are in order from most restrictive to least restrictive, all right? So if I combine the logical, the integer, and the double, the least restrictive is type double, and it's going to coerce everything into type double. So the true false, the true, when it gets coerced into numbers, the trues get coerced into ones, falses get coerced into zeros. The 1 will remain a 1, and the 567 will remain a 567. So logical integer double becomes 1, 0, 1, 567, okay? And the type of is double. When you combine the logical, the integer, and the character, it will coerce everything into the least restrictive data type, which is the character. And so it will take the true, and when it coerces that into character, it becomes true, all caps true in quotes, and all caps false in quotes. Okay, so this is the logical, the integer, and the double. Okay, and that's going to be type character. Coercion happens kind of automatically and on the fly in R, and it doesn't complain. So if I have this vector, false, false, true, and if I coerce it explicitly into numbers, I'll get the value 0, 0, 1. But I don't even have to do that. I could just take this logical vector and say sum, and R is internally going to coerce everything into zeros and ones, and it will sum them all up, and it will basically get the total count of how many true values we have. How many ones do we have? We got one of them. If you ask for the mean, it's going to convert this 0, 0, 1, and you're going to get the proportion that's true as well. And so that's a very handy thing, and you'll see that very frequently. You'll just have kind of this column, and you'll just say mean of, x greater than 7, and what proportion of values are greater than 7 there. Okay. You can explicitly coerce things using the as functions. So you can do as character, as.logical, as.numeric, and R is going to do the best that it can. Obviously, when you do as numeric, it's going to coerce things like quote, 0 in quotes, 1 in quotes, that can do that. But if you try to give it something like as numeric, quote, dog, it's not going to be able to do that. So it's going to say NAs. NAs are introduced by coercion. Some rules regarding coercion. When you do as logical, basically zeros get coerced into false. Everything else gets coerced into true. And nans get coerced into NAs. So 0 becomes false, 1 becomes true, but so does -1, 0.1, 2, negative infinity, a really tiny number like 2.2 times 10 to the negative 308. Those all get coerced into true. Only 0 gets coerced into false. Nans get coerced into NAs for missing values. Okay? When you do as logical, these will all get coerced into false. These are the accepted spellings for false. Capital F, all caps false, capital F-A-L-S-E, and then lowercase F-A-L-S-E, and then these all get coerced into true. Every other spelling gets coerced into NAs, okay? So lowercase f, NA, lowercase t, NA, cat, or whatever, that's all going to be. What happened here? Because when I did as logical on the 0, 1, that became false and true. What happened here when I did as logical on the 0, 1 here? I got NAs.
It became a character first.
Yeah, so first when you combine it, right? So when you read functions, it does the inside function first. And so we're combining the 0 and 1. So these zeros, the 0 here got coerced into quote 0, okay? And quote 0, when you say as logical, will become NA. Numeric value 0 becomes false. Okay, R is special in that it has an NA. Okay, we have NA, we also have null, and we have nan. And what's the difference between these things, okay? NA is used to represent missing or unknown values. We have an NA for each data type. Null is used to represent things that do not exist. Okay, so it's kind of like your none. If it doesn't exist, it's a null, and it's its own data type as well. Nan is always going to be type double, and it's used to represent kind of indeterminate math forms, I guess. Numbers that aren't numbers or things like that. Okay, so the example here is when would you use an NA, when would you use a null, okay? Again, NA is for values that exist but you don't know. Null is used for values that do not exist. So let's say we're including information about people and maybe their partners. And so we say Joe is a person, okay? But we don't know Joe's age, okay? But Joe does have an age even if we don't know it. So we're gonna write NA for Joe's age. What is Joe's age? NA. It exists, but we just don't know it, okay? Some people have partners, some people don't, okay? Joe does not have a partner. So if we wanted to have something for the partner's name or the partner's age, we would write null because that doesn't exist. Joe does not have a partner, so there's it's not a missing value. It's not something unknown to us. It's just something that doesn't exist, okay? If Joe did have a partner and we didn't know the partner's age, then we would write NA, right? So that's the difference between when you use NA and when you use null. As far as NAs go, we have an NA type for each atomic vector type. The default NA is type logical, so you could throw an NA into a logical vector and it's not going to coerce it into anything else. It will remain logical. And if you have an integer vector, there's an NA for integers. Now, if you include the NA into the integer vector, it will just automatically get coerced into NA underscore integer, which is the integer NA type. But when it prints out, R just prints out NAs. But again, everything in an atomic vector has to be of the same data type. And so the NAs there are correspond to that data type there. Don't do NA equal NA. That will always result in an NA, basically a missing value. It's kind of like that's like saying, here I've got a value inside this pouch, we don't know what it is. There's another value inside this bag, and we don't know what it is. And I'm asking, is the value in here equal to the value in here? And the answer is, well, I don't know, okay? So you're gonna get an NA there, okay? The question is the value in this pouch known or unknown, okay? When you do is NA, that's gonna come back and say true. It is unknown to us. Is it unknown? Yeah, I don't know what that is, okay? Similarly, for null, the type of null is its own data type, basically something, we use that for things that don't exist. And if you want to know, is it the null object, you say you do is null, that's true. If you ask any kind of logical question on the null, is NA on the null, that's going to come back and say, well, that's logical 0. Logical 0 means the response is a logical vector, logical type, the length is 0, okay? It's a logical vector of 0 length. We don't have a thing, okay? Nulls are kind of like things that don't, for things like that, okay? So, but is the null object, is it a logical data type? No, that's not a logical data type, okay? When you try to do arithmetic or operations with null, you're gonna get a 0 length vector. So if you do null plus false, okay, the plus operator coerces the false into an integer data type of 0. But again, you can't do null plus something, and so you get an integer vector of length 0. If you try to insert the null into a vector, like combine it with 4, 5, and 3, this is like inserting nothing. So this length is a length 3 vector. It's just 4, 5, 3. The null just doesn't exist, okay? And again, no, don't bother asking, is null equal to null? That's not how that works, okay? Let me give you your last view quiz answer. Last view quiz answer is the letter A. A as in apple. A as in apple. Okay, we have some vectorized arithmetic. I think you are familiar with this. And basically, R is going to match things up element-wise and do things accordingly. So if I have this vector 1, 2, 3 for x, the vector 100, 200, 300 for y, and I say x plus y, it matches the 1 with the 100, the 2 with the 200, the 3 with the 300, adds them up or multiplies them. Okay, 2 times 200, 3 times 300. R also recycles. So if you have a longer vector and a shorter vector, it's going to take the shorter vector and recycle the values until it kind of matches everything up. So if I do 1, 2, 3 plus 100, 200, 300, 400, 500, 600, it matches the 1 with the 100, 2 with the 200, 3 with the 300. Then it recycles the 1 and it matches the 1 with the 400, the 2 with the 500, and the 3 with the 600. If you do something where the longer vector isn't a multiple of the shorter, it will still recycle, but then it comes back with a warning and says, are you sure this is what you wanted me to do? Okay, because I did 1, 2, 3, and then I did 1 with the 400, 2 with the 500, and then I had this thing left over. And so I'm not sure if this is what you wanted me to do. So it does that. Here I have a matrix, and here I have a vector, 100, 200, 300. Now keep in mind, R operates with matrices column-wise. So this is different from, say, Python. If you took this matrix and you added 100, 200, 300, Python would broadcast, and it would add the 100 down the column, 200 down the column, 300 down the column. But R does something different, and it's going to add the 100 to the 1, and it goes down the column, and it adds 200 to the 4, 300 to the 7, and it recycles 100 to the 10. And it goes back to the top, 200 to the 2, 300 to the 5, 100 to the 8. And R, because they match up, right, it reaches 1, 2, 3 at the bottom over here, 100, 200, 300, it doesn't see a problem that says, here's your answer. Again, if you're not paying attention, you might not realize that there's a problem. Okay? Or maybe this is exactly what you want it to do. But if you wanted it to add across the rows, then you have to kind of think within R's paradigm. And so how would you do this? Well, R is always going to add column-wise. So if you wanted it to add 100 down the first column, 200 down the second column, and 300 down the third column, what you'd have to do is there's a little trick here. Okay, you transpose that original matrix. So now we have 1, 2, 3, 4, 5, 6 down the columns. Then you add 100, 200, 300, so they get added down the columns accordingly. And then you transpose the entire thing back. And now you get 100 down the first column, 200 down the second column, 300 down the third column. So that adds up accordingly. Okay, that's it for today's lecture. We'll wrap up here. Make sure you spend some time just reviewing these notes and get started on your homework, and we will see you all on Friday.